Hello. So today we're going to do an image classification on a dataset that contains three shapes: circle, square, and triangle, that is represented as pixels. Okay, and then we have the label at last. It's 625 pixels per image. We use three different methods. So the first one is classification using logistic regression, and we can see that we use the solver LBFGS. We have accuracy, precision, and recall scores that are alike and that are approximately 0.75. And then we just printed some of the images, and we printed the predicted label and the actual one. Then we used the CNN, convolutional neural networks, to do the classification. And we can see that with each epoch, the accuracy, precision, and recall scores get better. And we have a really good score at last. And then we use the classification using linear SBC, and we can see that we have scores that are pretty similar to the ones we got with the logistic regression. We also did an autoencoder on the same dataset. We can see that we created an encoder and a decoder, and basically the encoder takes an input that has a shape of 2525-1, and the output is the same as the input of the decoder, that is 1132.
Now in the autoencoder, we did the training, and we can see here we used 200 epochs, gave us better results than lower epochs. We did an image reconstruction function in order to show the actual image with the one that the autoencoder gave us, and we can see that the results are pretty accurate. So yeah. Okay, so we're now talking about the clustering. To begin, we loaded the dataset, which is the penguin dataset. We did some pre-processing by eliminating any null values and shuffling the data. And then we did some data visualization. It's important to note that we got really good defined clusters when we used the common depth and body mass for the scatter plot. And it's going to come in handy later on. We did a build model function, which takes a function such as mean shift or other functions, basically models, clustering models. We did it with the mean shift. The silhouette score is pretty bad. With the affinity propagation, we can see that it's much better. And we did some hyperparameter tuning for k-means to find out which is the best number of clusters. We realized that 2 clusters gave us the best silhouette score, which is much better than the ones we saw before. And then we did it with the common depth and body mass, which we realized were the best to show us clusters in data visualization. And we did that so we can visualize the centroids like so. And we also did the agglomerative function, which does the clustering and give us a good silhouette score